Botswana is endowed with star power. It is not the Hollywood type of star power, but it is power from the brightest star in our sky, the sun. Sunlight is the most abundant source of energy on Earth, a gift from the gods, free. But free does not mean readily available if your idea of power is electricity. So, we must first harvest it. Just off the A1 as you enter downtown Gaborone in Sebele lies this field, which has been transformed into a world-class solar power station. This field harvests solar energy and converts it into electricity for consumption by the Botswana University of Agriculture and Natural Resources, BUAN. At inception, BUAN had the wisdom to treat this project as a business.
The concept started in 2019 after BUAN had done a strategy, I think, and transformation. I think that was about 4 or 5 years. I think in 2014 or 15, when they introduced the business development department. We set up a company called BUA Enterprises, which is 100% owned by BUA. And within the company now, there had to be projects. So the university ultimately leased this area to the company.
This project is the envy of many in a world which is way too far to attain the status of a Type 2 civilization on the Kardashev scale. A Type 2 civilization harvests all its energy needs from its host star. To combat climate change, projects like these need to be proliferated. But funding for solar power stations that can make a meaningful contribution to combat climate change is the ultimate Achilles heel.
After the lease, we had to establish a budget for the project, to raise funding for the project. But there was no money available within the university budget to do this project. Then we raised money from Europe.
There were many challenges that dogged this project at its inception. To rise to the challenges, business entities, locally and abroad, collaborated to deliver the first large-scale solar power station in Botswana.
We started off with this project with a company called Stics from Germany. So Stics was working hand in hand with a local company, which is popularly known as Solar Hut, that called Energy Systems. I think it's very important to also mention at this stage that for BUA Enterprises to be able to make this project work, it got into partnership with a strategic partner from South Africa called MarketVest. So MarketVest and BUA Enterprises formed a special purpose vehicle basically for this project. And that special purpose vehicle is called AgriVault BP2TD. Agri, which is agriculture, Volt, which is electricity, and BE being BUA Enterprises. Construction started in December 2021. So even during constructions, there were hurdles because when we were drilling here, there was water, there was rain, there was everything that, a lot of things went wrong, but we persevered, and as you see, the project came up and is operational and is feeding the university.
Solar Hut has been providing renewable energy solutions to its customers in Botswana for over 30 years. The company's products are designed to efficiently harness the sun's energy. The solar power field is a natural playing field for Solar Hut.
This project, it's a 1 megawatt solar power plant for BUAN. It has been done as a pilot project to actually find if there is a fit between power production and also production of food.
Initial planning for a plant of this magnitude is on paper. A conceptual design created using various softwares entails mapping the layout of panels, tables, and cables. Once the stage is approved, fieldwork begins.
The first part, obviously, is to set out, because we need then to be able to set out all the positions of the tables, all the positions of the mini substations. Then the second step obviously would be the installation of the structures for the panels. So we had to install the struts, what we call the struts. These are the vertical columns which actually hold the panels and the upper structure. Then we started our paneling. Then after our paneling was done, the next step was actually the actual wiring of the panels. So we had to string our panels together so that they conform to the design or to the wiring arrangement of the plant. Then after the stringing was done, we had to go further to install the inverters. Then we went on to install our mini substation so that we are actually able to step up the power to the required voltage and for tying in to the existing BPC grid. We went on to do our AC cabling. Then after that, we went on to construct a new 11 kV overhead line. We then started our testing processes, our QC checks, and our commissioning processes.
Botswana Power Corporation has an ongoing scheme called the Rooftop Solar Program, where citizens generate solar power for their own domestic consumption. The excess power generated by these homes can then be sold to BPC and fed onto the utilities grid. This type of arrangement is called the grid-tied system.
The grid-tied system, it works together with BPC. So basically what happens is that depending on the output power of the solar power plant, the plant can actually supply all the load, or if the output of the plant is insufficient to cover the load, the remainder will come from BPC. Remember, this is a photovoltaic system or plant. It's active when the sun is shining. So which means whatever power that we are producing is going to be produced between 8 and 5 o'clock. Then at night, the facility then has to use power from BPC. We are using the grid as more of a virtual storage. So whatever power that we send to the grid during the day, we also have access to that power at night. Let's say, for example, the plant has produced 100 kilowatt hours and the facility has only consumed 60 kilowatt hours. It means the 40 kilowatt hours remainder is being fed back to BPC. Now BPC is going to make provision for a bi-directional meter. So this is a meter that can actually measure power flow in either direction. So if you are pushing power to BPC, it's going to count those 40 kilowatt hours that are going to BPC. Now at night, you start to draw the 40 kilowatt hours that you have been pushing during the day. When those 40 kilowatt hours are finished, then BPC can start charging you for the extra units that you would need to consume.
University consumes about 4 to 500 kilowatts, and then the rest of the energy goes back to the grid. The bill before the plant was monthly bill was about 750,000 pula, and now it's hovers around 250,000.
You all understand that BPC is always increasing their tariffs on an annual basis. But if you're looking at getting power from a solar power plant, you're looking at locking down your tariff level. Over the next 15 or 20 years, you're going to be enjoying power at a constant tariff. So that then helps you to reduce your energy bills in the long run. Plant can generate power at a rate of 1,000 kilowatts. Now, when looking at households, a normal household would consume around 13 kilowatts, let's say, for example. So you're looking at almost close to 100 or more households that can be powered from this plant. But in a nutshell, this plant is going to sustain the whole of Buan.
This renewable energy from the sun produced in this plant reduces the load on BPC, which in turn reduces the amount of thermal power BPC produces. It does not require a mathematician to realize that this tied grid system makes our Earth smile a little, since it reduces the emission of greenhouse gases into the atmosphere. This prevents global average temperatures from rising. The design of the solar panels in this plant makes it very efficient. For the plant to be this efficient, all the panels are not fixed in one plane, a first for Botswana.
This is one of the projects also in Botswana where panels have been installed in such a way that they're actually going to be able to track the sun. This is a single axis tracker, which means it actually moves in one plane. So our panels, they actually move in the east-west orientation. So there is a software or a controller that is there which ensures that the panels, they actually move and track the sun at various intervals throughout the day. At night, the panels, they automatically go back to their horizontal or resting position, which is the position which is required to ensure that the panels, they do not get damaged by winds or bad weather conditions.
Buwan is an institution of higher learning. Its student body must lead the country in new ways of doing things as the years roll by. It is here in this field that a variety of studies can be conducted.
This project has got 3 stages. The first stage was to build the solar. The next stage, which has happened now, was to do the crops under the panels. And the project offers a lot of opportunities. It's a very interesting project to the public at large, but also to the university, as it presents a lot of research capabilities. Students also come here to learn the practical way of setting up the panels. They are taught when they see them working. So it has presented quite a change in the whole university, budget-wise, research-wise, and also in the look and feel of the school.
Additionally, research engineers will get an opportunity to do a study on the efficiency of solar panels that track the sun against solar panels that are stationary. Buwan is the foremost agricultural research institute in the country. This project will help researchers study how crops perform under the panels.
So this is being done as one of the first projects in Botswana as an agrivoltaic system, where you use the same land to generate power and also produce food.
We put 30,000 tomato plants and 15,000 green peppers. We expect 30 tons of tomatoes and 20 tons of green peppers. But as I said, it's every 3 months. So after 3 months, then we plant again. So basically, the revenues will be perpetual. I'm going to test some natural resources here. We are going to plant in a few days, maybe in 2 weeks' time, rotwe under the panels and delele. And then we are also going to plant tepe. So I think when we harvest around March, you should find Merogo as it's on.
This solar power station has a life expectancy of 20 years. It is also expected that the plant, as is, will be able to realize a return on investment in about 7 years. This therefore means the solar panels have to undergo periodic maintenance for the plant to power through the years ahead.
Part of the maintenance would also involve checking the cables that we have, tightness of connections, checking our inverters for ingress of dust, insects and the like. This is a tracking system, which means there are a lot of moving parts. So from time to time, we are going to be coming, checking the tightness of our bolts and nuts, checking out for normal wear and tear of the various moving parts and replacing them as such. Naturally, panels get soiled due to dust. So we need then to be able to clean them periodically so as to maximize the output from the plant.
Botswana is one of the brightest countries in the world. The country receives the brightest of sunshines, yet we are not tooling ourselves enough to exploit this accident of nature. As a people, we need to build more solar power stations so as to reduce the global carbon footprint.
We want to replicate this throughout the country. To the mines, to the farmers, to the public at large, and as Buwan Enterprises, we want to offer solutions to anybody in any industry, solar solutions.